This is June 06, and it was an A2 Module 4 question on June 06. And again, this is Hooke's Law and Young Modulus style question. State the principle of conservation of energy. So that's a nice easy one. You've known that since first year. And it is, of course, that energy cannot be created or destroyed. But simply changed. From one form to another. Give a practical example of a case in which kinetic energy is transformed into thermal energy or heat. So any kind of example would do, but say rubbing a surface with sandpaper. That's your kinetic energy, rubbing the surface with sandpaper, and that friction converts that into heat. Car brakes, for example, and the list will go on. Part B, a ball of 0.25 kilograms is held at rest above a vertical coiled spring of constant K. The spring constant is a constant of proportionality in Hooke's law. Initially, the bottom of the ball is 0.5 millimeters above the top of the uncompressed spring, as shown in figure 1.1. The ball is then dropped, so I'm just reading from the next part of the question. There's quite a wee bit here. The ball is then dropped through a distance of 0.55 meters so that it falls on the spring, and it then compresses the spring by a further 0.15 meters. Figure 1.2 shows the spring at the instant of maximum compression when the ball is again at rest. In the calculations below, air resistance can be neglected. So the first question says, calculate the loss of gravitational potential energy of the ball between the two situations as shown in figure 1.1 and figure 1.2. So obviously that's mgh, and h is that 0.55 plus the 0.15 is how much gravitational potential energy it has lost. So the height that it's fallen through is 0.55 plus 0.15, so it's a distance of 0.70 meters. So GPE equals mgh, and that's equal to 0.26, which is the mass of the ball, 0.26 kilograms. G is 9.81, and h is 0.70 meters. And that gives you an answer of 1.79 joules. State what has happened to this energy, and it is now stored as elastic potential energy in the spring. Hence calculate the spring constant. So we know that strain energy or stored energy is half Fx, and the energy is 1.79 joules, and that's equal to half multiplied by, sorry, we're going to use this equation because we haven't got F, half kx squared, and so we're looking for k. And x squared then is our 0.15, which is the compression of the spring, and it's squared. So when you rearrange that, k is equal to 2 times 1.79 divided by 0.15 squared. And k comes out to be 159 newtons per metre.